IDENT stands for Intelligent Digital Enhancement and Notation Tool and is meant to be a rapid analysis tool that uses algorithms for the systematic analysis of fingerprints. This is the first tool to be created by AI by simply uploading scientific papers on feature extraction and clarity maps, and then refined based on its real-world performance through conversation with a latent print examiner. The tool acts largely like an APHIS enhancement and encoding tool, but doesn't require the use of an APHIS system. The parameters of the algorithms have been brought out into the tool and can be altered to dial in the most accurate application while still retaining the speed and efficiency of automation. While humans exceed the accuracy of most algorithms, this tool allows for a systematic, contemporaneous, and efficient way to create documentation and rapidly analyze fingerprints. Using the tool is easy. Load a fingerprint image into the user interface. Once loaded, simply click the Encode button. IDENT will tell you what it is doing through the user interface messages in the upper right-hand corner. It will apply algorithms in the background, and when it is done applying the algorithms, the layers will be available to view. Simply click on the checkbox of the corresponding layer to view the output. The name of the automated process is listed in the layer itself. Additionally, each layer contains a slider which allows you to reduce the opacity in order to see the underlying layers. The original image is the fingerprint image as it was first uploaded, without any processing. The normalized image is a clearer version of the original image, where the brightness and contrast have been balanced to make the fingerprint ridges more visible. Segmented image separates the actual fingerprint from the background, focusing only on the important parts. The orientation field shows the direction of fingerprint ridges throughout the print using colored lines, helpful for seeing the overall flow pattern. It is used to tune the Gabor filter. The clarity map is a color-coded view showing which parts of the fingerprint are high quality, good, medium quality, bad, or poor quality, ugly. The Gabor filter is an enhanced version of the fingerprint, where the ridges are made clearer and more defined. It is directly used as input for skeletonization and indirectly affects how accurately minutiae are found. Skeletonization reduces all the fingerprint ridges to thin lines, making it easier to analyze the pattern. Minutia marks important fingerprint features like where ridges end or split into two. Singularities identify special points in the fingerprint pattern where the ridge flow changes direction significantly. This can include the core or deltas of various fingerprint patterns, but it can also include some distortion where the ridge angles change significantly as well. And this is what we're seeing right here. You can make changes to two layers currently, and that includes the minutia or the encoding and the clarity map as well. And we'll take a look at that. So for the minutia extraction, once you click the manual mode, a set of sliders becomes available, which has some parameters. Now, these parameters will allow us to fine-tune the encoding. So for the quality threshold, this controls how selective the system is when identifying minutia. Higher values mean only minutia and clearer, higher quality areas will be detected. Lower values will detect more minutia, but might include more false detections. We can experiment by bumping this up a bit. The min distance sets the minimum spacing required between detected minutia points. Larger values force minutia to be more spread out, reducing duplicates. Smaller values allow minutia to be closer together, but might lead to multiple detections of the same feature. We'll leave that as is for now. The block size controls the size of the regions used for analyzing the fingerprint. Larger blocks make the analysis more stable, but might miss fine details, and smaller blocks capture more detail, but might be more affected by noise. Let's lower that just a hair and see what happens. The boundary margin sets how far from the edge of the fingerprint to ignore when detecting minutia. Larger margins exclude more on the edge areas where minutia detection is less reliable. Smaller margins allow detection closer to the edges, but might include more false detections. We'll bump this up because we can see in this image that the minutiae around the boundary the false minutiae seem pretty prevalent. And so after we're done setting our sliders, we can click the re-extract button, and that will force the minutiae to be re-extracted, and the layer will automatically load when it's done. And we can see here we have a little bit more precise, I guess you could say, extraction. We still have some boundary cases which we may want to try to enhance and get rid of, maybe by reducing the minimum size or increasing it, since we didn't do that yet. But you can see that there is a difference when adjusting these sliders. And this holds true for the clarity map as well. So if we show our clarity map, and we'll take out the underline layers and reduce the opacity so we can see it. Now, once you click manual on the clarity map detection, the clarity map calibration becomes available to use. And so we can vary these parameters as well. And this allows us to primarily deal with orientation and Gabor settings, because those are the two features that are considered when creating the clarity map. So for the orientation threshold, this sets how closely ridge directions must be aligned to be considered good quality. Lower values are stricter, the ridges must be more parallel, and higher values are more lenient. It allows for more variation in ridge direction. So we can try taking this down a little bit. The orientation threshold for bad determines when regions are marked as ugly due to poor ridge alignment. Areas with ridge direction variation above this are considered very poor quality, and it should be higher than the good threshold. Can bump this up a little bit. The Gabor threshold for good controls how clear and well-defined ridges must be to be marked as good. Higher values require stronger, more defined ridges, and lower values are more lenient on ridge definition. We'll leave that as is for now. The Gabor threshold for bad sets the minimum acceptable ridge definition. Areas below this threshold are marked as ugly, and this should be lower than the good threshold. And then the last two are how much weight to be given to the orientation settings and how much weight should be given to the Gabor settings. So if we take the orientation settings down, bump up the Gabor weight a little bit, with these settings, and we can recalculate our clarity map. It's thinking and applying the algorithm in the background, and we can see that the map has updated. So areas that are now considered bad or less clear than the good have changed. And we can see that this has also changed our overall quality. Now we can fine tune this until we get to a quality level that we think this is. This is a pretty obviously good print, so it should be a little bit higher than 82, but we can fine tune that with these sliders. So when you're happy with all your calibrations, you simply click the Create Documentation button. And this will take the most recent layers and put them into a document side by side, where they can then be downloaded and saved into a LIMS or printed out and put into a case jacket. And you can zoom in and see all the features there. There's our most recent clarity map. So what are the benefits of a tool like this? Well, it offers consistent, reproducible processing across different examiners. It provides quantitative measures for quality assessment. This could help establish standard operating procedures for print analysis. This could assist in documenting why certain prints are determined of value or no value. These tools could be particularly valuable for training new examiners, quality assurance reviews, or documenting analysis procedures, or supporting conclusions in court testimony. If you have questions or are interested in having me create a tool for you, reach out to me on LinkedIn. Thanks for watching.